Let's go through Liquid 730. Count different palindromic subsequences. For this question, it gives us a string S, and let's count the different palindromic subsequences. So let's look at the example BCCB. There are 6 different non-empty palindromic subsequences. So those are B, C, BB, CC, BCB, BCCB. You see, this BCB, if we use the index 0, 1, and 3, right? And 0, 2, and 3, they both to be BCB. So we just keep 1. So it asks what's the total number of the palindromic subsequences. So let's look at if we need to see we can see if we have for example int I use this kind of formula, right, called dpij represent from, because for this kind of palindromic problem this kind of dp is a very classical way to solve this. We use dpij to represent how many distinct palindromic subsequences from the index I to index j, right? So let's look at how we are going to have the transition functions, right? So we know the initial function is that dp I, right, for every I2 from 0 to n will equals to 1. This will be the initial condition. And what we return will be dp 0 and minus 1, right? But we need to find the transition function. Let's consider how can we transfer. So there are 2 kind of scenarios. If first scenario is if this kind of char I doesn't equals to char j, right? If it doesn't equal, then dpij will be, so let's say this is your dp index I j, right? If it doesn't equal, then we'll say we already calculate from I to j minus 1. We also calculate I plus 1 to j, right? And also we calculate the comma part. So dpij will be dp I plus 1 j plus dp I j minus 1 minus dp I plus 1 j minus 1, right? So if this doesn't equal, right, we just calculate the counts from this one and this one and minus the comma part. So this is straightforward. But if this kind of ij, they are same character, for example, both to be x. So how can we, how many distinct subsequences we have? So it has 3 kind of scenarios. The first scenario is that let's look at from this I to I plus 1 to j minus 1, right? If there is no x inside of it, so what happened is that if there is no x, we'll see for every palindromes in this kind of intervals, for example, we have AA, right? For this AA, or what we can do is that we can just have x on the left and x on the right, right? So for every palindrome in this kind of interval, it will have a pair or part, right? A parity, which we add a x on the left and a x on the right. So that means the distinct counts will be 2 multiplied by dpi plus 1 g minus 1, right? And also there is another scenario is that we also need to count the subsequences of x and xx, right? They are also palindromic subsequence. So that will be this one plus 2, right? And so this is a scenario where there is no x inside. And another scenario, the second scenario is that there is one x inside. So if I and j, they are both x, and also from I plus 1 to j minus 1, there is an x here, right? So we have the same thing, right? That for every distinct polynomial subsequences in this kind of x plus 1 and j minus 1, we can add a x on the left and an x on the right, right? So for example, we have z x z, right? We are able to add a x and an x here, right? So every distinct polynomial that will have a part, right? A parity. So dp ij will also be 2 multiplied by dp I plus 1 j minus 1, right? But the thing is that you see, it already have those kind of distinct polynomial of x already, right? So what we need is only xx. So we're only plus 1. So this is if there is only one x inside, how can we handle it, right? The third scenario is that for this kind of dpij, right, x, this is x, right? And there are more than greater or equal to x is inside in the inner interval, right? So how can we handle this? So if there are more than 2, what we do is that we'll say we are having this part to be for example xi plus 1 and j minus 1, right? We extend, for example, any distinct polynomial subsequences by adding an x on the left and an x on the right. For example, we have an a b, right? ABA, right? Then we can have an xx, right? So intuitively, what we think about is also the dpi plus 1 j minus 1. But there is some kind of scenario is that there is some distinct polynomials inside of the first x from its left, right, and the last x from its right. In this kind of intervals, for example, there is an AA here, right? We'll calculate how many distinct polynomial subsequences from this kind of range. Let's write this kind of range. We already have the x, a, x, right? So when we calculate this part to this part, if we still add x, a, x, it will be duplicates, right? So what we are going to do is that we are have the two dp I plus 1, j minus 1, minus the counts of distinct counts of here, right? So for example, we call this is left, this is right. So we're minus dp left plus 1 and j plus 1, right? So that is the three transition conditions. In that case, in the end, what we retain is just dp 0n, right? But for this question, if we try to count every ij, how the next if there is x, they are equal, right? If we are trying to calculate the next x after I, right? Well, if we brute forcefully to calculate next, then for every ij that will a linear operation. So the time complexity for this kind of interval dp will be O n square, but this operation is also n, right? So that will be O n power 3 time complexity, which should be O n time power 3. That's not good because the n is 10 to the power 3, right? Theoretically, it will be 10 to the power 9 time complexity. We should be some way to optimize it, right? So how can we optimize? We'll see if we want to see this kind of right, the first character after index, which have the same character with this chart, right? We'll see we can pre-calculate. We can use a pre-array for those 26. That actually there are only 4 characters. And also a next arrays for the 24 hours. So the first time we go through this kind of string in a pre-process this pre-array and next array. Or we can call left or right, right? Left array or right array. Then for this x, if we want to find the first x after I, we just check this kind of right array. And also we want to check the last x previous to j. We just check the left j, right? So that we can get O(n) power 3 to O(n) power 2 time complexity. So let's write code for this. We need a mod, right? Private static int mod equals and let's have int n equals let's have change this one to array. So we are going to have int n equals array dot length, and because we want to mod, right? So it's possible when we calculate it, it will be out of the bound of the integer. So let's have a long dp equals new long and right. So what we do is the initial condition is that for every int I equals 0, I smaller than n, I plus plus have dpi I equals 1, right? And we are going to create a right array. That means for every I, array I, right, char I, what's the next index for this? And also let's have an left array, right? That means the previous one. Uh, and we can have something called pre equals new int 4. That means we have 4 characters, right? So what we do is that arrays fill pre to be -1. Arrays fill right to be, for example, n, right? And arrays fill left to be -1, right? So then what we do is that for int I equals to 0, I smaller than n, I plus plus. Let's pre-process this kind of right array. Right means for the if we have a character char at array I, all right, that is char. That means after this index I, what's the first in position or index for this kind of chart, right? And then that is left is the last, right? So we'll say int index. This index is the pre-array. We use this pre-array to store ABCD, right? Equals array I minus A. Okay. So we'll say if this kind of pre index doesn't equal to -1, then we'll have right pre-index should be equals to I, right? And left I equals pre-index. And then we should also always have a pre-index equals, right? In this case, we have calculated the left array and the right array for every index. Then what we do is that for int length equals 2, length small equal to 2 or to n, right? And the length plus plus. For int I equals to 0, I plus length smaller equal to n, I plus plus. So we'll say int j equals I plus length -1, right? So there are 2 kind of scenarios. If the character doesn't equal, then this is the simplest case, right? dp I j will be mod plus dp I plus 1 j plus dp I j -1 minus dp I plus 1 j -1 mod, right? Because there is a mod, a subtract, right? So to be safe, we always add a mod here. Else, that means if they have the same character, so we'll say int. So we'll say left equals right I, right? And right equals so we are trying to find that, for example, this is I J, and find that the first left is this one, right? First this is X, first X here, right is last X here, right? So right equals left I, right? So this is, we can use a pre-processing array here. So we'll say if left equals to j, right? That means there is no x. So we'll say dp I j will be 2 multiplied by dp I plus 1 j -1 and should plus 2, right? Because we need to add x and xx. Else, if for example left equals to right, that means there is 1 1x between I and j, right? So that we have dp I j equals 2 multiplied by dp I plus 1 j minus 1. 是的 plus 1 and mod, right? And the third scenario is that there are more than at least 2, right? So what we do is that this dpij will be, because x already been calculated. So what we need is that we should minus, right? dp left plus 1 and right minus 1. But this one, we should have mod because there is a subtract sign. So in the end, what we need is return. For example, we convert to int dp 0 and minus 1, right? To multiply dp I plus 1 j minus 1. There is minus 2 outbound for index minus 2. So why there is index minus 2? To multiply so this is actually left G. Okay. So the time complexity and the space complexity will both to be O(n) square. And we can also have Python code for this, right? So let's say we'll have n, for example, mod n dp, right? Mod will be 1, and n will be the length of s, and because we use n, let's have dp another line. dp equals multiplied by n for underscore in range n. For I in range, and we are going to have dp I equals to 1, right? And let's have free right left will be let's first minus 1 multiplied by 4, right? And minus 1 multiplied by n minus 1 multiplied by n, right? For let's pre-process the left and right array in range n. So we're going to have index equals rd array I minus or the A, right? So if pre index done equal to -1, then we're going to have right pre index equals I, right? And left I equals pre index. And after that, we have pre index equals I, right? So this is for the length equals to 1, we already processed. Now we need to process the length equals to length um, to n, right? For length in range to n plus 1. Then we're going to have for I in range n minus length um, plus 1, right? Then we're going to have j equals I plus length minus 1. So if array I not equal to array j, then the simplest case is dp I j will be, for example, mod plus dp I plus 1 j plus dp I j minus 1 minus dp I plus 1 j minus 1 and have mod, right? Else, else, let's calculate the left and right, right? Left, right equals, so this left, we need to calculate the right array, right? That is the first character um, after I, which have same character with I, right? So actually, array I and array J, they have the same character, and this one will be left J, right? So we'll say if left equals J, that means there's no X. That means we are going to have dpi J will be 2 multiplied by dp I plus 1 J minus 1 plus 2 mod, right? And else if left equals to right, right? That means there is an X limit at left or right position. We will have dp ij will be equals to this one plus 1. And the third case is that we need to minus, right? That's part 1, right? Minus 1. And we have a model here so that it will not be negative. So in the end, we just return dp 0 and minus 1, right? Should not be array, should be S. S. So this is also S, right? S. Multi, okay.